let's talk about the linear approximation, okay? But good news is this is not something new, okay? If you understand about the like tangent line equation, and this is exactly the same thing, okay? First of all, think about the square root of 1.1. Do you know the value of square root of 1.1? I'm talking about, well, we assume like it is like, since we know like square root of 1, which is equal to 1, like we assume this will be a little bit bigger than 1. Does it make sense? Okay. So basically this approximation, like estimation, like skill is the linear approximation. Okay. So let me give you the idea. Okay. Basically the square root function is the graph of the function looks like something like it is curve. Okay. So as we assumed, or we guessed from here, when x equal to 1, right? So we know about this information. Okay. So like I'm talking about, the function is this guy, okay? But we would like to talk about this point instead, okay? Which is x equal to 1.1 point, okay? But unfortunately, there's no way to find the value, exact value of square root of 1.1. Actually, it is irrational number, so there's no way to find, or no way to write this value as the like fraction form, okay? So what we're gonna do is we're gonna try to find the tangent line at this point, which is non-value, okay? Like that, okay? Then maybe like we can say this is tangent line or linear approximation, okay? As I told you, linear approximation is exactly the same thing with tangent line at the point, okay? And then now what you're gonna do is like, we're gonna try to find this value instead, because that is a linear equation, which means it's mx plus b4. You can easily find this value, okay? But can you see? Dun, 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 okay? The real value is the cross one, and the approximation value is over there, okay? So it is not exact value, but we can say it can be approximation. Okay, this is a linear approximation. Okay, since we are using linear equation, that's why it is linear approximation. Okay, so but still you have question this one. Okay, you're gonna ask me like this way. Hey JD, we have calculator. We can calculate square root of 1.1 by calculator. Oh, it is true. Okay, if you can use calculator, you can do that. But keep that in mind. We do not allow to use the calculator at all in this class, okay? So try to use your brain, okay? And you are not a slave of computer or calculator, okay? We can do it, okay? So, but like, again, like this is the way to approximate, but this is not the way to find exact value. There is no way to find exact value. By calculator, it is also approximation value, okay? So anyway, so this is idea, okay? Like, like let me summarize this, okay? What we're gonna do is like, if you want to approximate the value square root of 1.1, then since we know about the square root of 1, and we will find the tangent line at that point, then with that tangent line equation, we will find the approximation value like for square root of 1.1. Okay, this is the idea about linear approximation, okay? So look at this one. This linear approximation, do you think this is like strange one? Let me show you where this came from. As I told you, I can tell you the conclusion, okay? This guy came from the tangent line equation, okay? So let me tell you why, okay? So you remember like whenever we had to find the tangent line equation, we used y minus y1 equal to m times x minus x1, right? So like this one. With this one, let me try to write this one in calculus sense, okay? So first of all, the point. It is x1 comma y1, right? But like in our study, we did a comma f of a, which is the given point. For this one, it is x equal to 1, okay? Then what is slope of tangent? It is noted by f prime of a, okay? Just putting back this value instead of m, x1 and y1, okay? Then your linear equation can be written by y minus y1 m x minus x1, okay? So just add f of x on both sides, okay? But like I'm not gonna write on the behind, but I'm gonna write f of a in front of this guy, okay? Then I can say y is equal to f of a plus f prime of a x minus a, okay? What is that? That's exactly the same thing which I stated in the linear approximation, okay? So now we can say that is linear approximation for your function f of x, okay?